I'm Stephen Foskett, organizer of Tech Field Day, and we are here in Austin, Texas, with a group of international delegates who've come in to learn and discuss and ask questions and interact during this technical presentation. You're about to hear from Uila, which is a new company to this audience, and I know that there will be a lot of discussion. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can also go to youtube.com/techfieldday to see more videos like this.
The next demo, I'm going to talk about Uila's infrastructure monitoring with the application context. Again, I'm going to switch to the dashboard. There's another view I want to show you, which is storage analysis view. Right over here, as you can see, the timeline right now reflects the read-write latency and read-write IOPS for the whole data center. It's very easy for you to pick the problematic time period. And the whole graph, below the timeline got refreshed right away, right? As you can see, there's 5 columns on this graph, respectively. It's physical disk, logical data store, host, VM, and vdisk. On each level, there's multiple bars. Each bar represents one entity, right? The width of the bar or the ribbon is decided by the IOPS usage. Very quickly, you know who's the heaviest user at this time being. For example, this guy is red, and it's very long. This is the heaviest user, and on the top of that, it suffered a long latency issue. One click on this bar, the tooltip telling you, take a look at the read-write latency. It's very long. And unfortunately, it's serving some application. And here, we allow you, we're weaving the application context by telling you what kind of application is running on this VM, whether they are performing good or bad. Again, you can do root cause analysis to find out the correlation between application response time and the storage problem. One click on HTTP service, we circle back to root cause view again. This time, we find out the strong correlation between the application degradation and the structure latency, the storage latency issue. Okay. The next one, I'm going to talk about the CPU analysis.
So with the storage, is it monitoring just IP-based storage, or can it see like fiber attached or like local disk storage if you're doing like a HCI?
Oh, whatever data store you are using or storage you are using, as long as it show up as the logical data store in the vCenter, we can keep track of it. Okay, we can collect the statistics from it.
Okay.
And then we can go beyond one layer, go beyond that layer to go to the physical disk where the data store, where the logical data store is attached to.
Okay.
Pull out the statistics and group them together.
Yeah, like hyperconverged system. We supported vSAN, we supported fiber channel, iSCSI, NFS, all these. They all hook up to VMware, and we all have way to get to that.
Okay.
So far, we haven't encountered any storage system that we are not able to visualize like this.
Thank you.
This is a CPU Treeview, and we illustrate the CPU picture like this. Again, the top line, on the top, the 2 trending charts reflect CPU ready time and CPU usage, which are 2 key CPU metrics for the data center. Again, if you're focused on this time period where the CPU ready is high, the graph below got refreshed again. At the frontier, at the root, is your data center. Right now, your data center is orange. It's not perfect. And by following the ribbon, the orange ribbon, you quickly chase down what's the culprit on the cluster level, which happen to be standard cluster in this case. And following the ribbon again, you chase down the host level culprits and expand the host. You can see all the VMs. And quickly, you find out what's the culprit on the VM level. So in this case, this VM light up as orange. As you can see, the tooltip telling you the CPU ready is very high. And it's serving my SQL service, right? It's not running well. So one click, on my SQL service, you can do root cause analysis here. Give it a moment. So on this root cause view, you know your application performance degraded. And in this case, as you expected, the primary reason is CPU health. Right? We can click into the CPU health to look into the detailed picture. We lay out the CPU information, including CPU ready time, CPU usage, CPU macros across all 3 levels. The first level is the virtual VM level. Then it's the physical host level and cluster level. Right? In this case, you know the CPU ready is very long across all 3 layers. And also you know on the VM level, the CPU usage is not high at all. Then what's going wrong, right? That drags your attention to the host CPU usage level. As you can see, on the host level, the CPU usage is approaching the limit. To figure out who are using the resources at this moment, one click on the bar, this breakdown list telling you, okay, there's a bunch of VM who are using the resources a lot, right? And those are the noisy neighbors. This is another example of noisy CPU neighbors. And those VMs, you're pushing the host CPU host level, CPU usage on host level higher. And my VM, which is Oracle 11 Gen 4, suffered the long CPU ready time. So basically, it's waiting for VMware to swap in some resources from other peers, right? That's why he has to wait, your performance degrades. The key takeaway from this picture is, as you can see, we try to connect the dots, right? From the application performance down to the virtual physical infrastructure, and more importantly, sorry, let me close this. And we can connecting the dots to the process level, because sometimes if your VM is very busy, right? CPU approaching 100%, you want to figure out which process in this VM are consuming the resources at the moment. That's when this process panel become very important, right? So the way we differentiate from we realize is, we not only provide you the physical and virtual information, we really try to stitch application information, infrastructure information, and process information together to give you the whole story. Please.
I'm not sure I've had time to properly format my question, so if you will, please bear with me. Are you able to, as an admin is now drilling down and finding where the problems are, and I believe I've seen you be able to identify services and insights about virtual machines as well as the network that they passed. Are you able to say, oh, this impacted application stack, and this tier is scale eligible? So it's something that can be horizontally scalable, such as interacting with vCenter to trigger other instances to be created, or Kubernetes to horizontally scale that application stack. As the admin has found and confirmed that there's a problem, is there the capabilities currently or future, not knocking, just asking, where that admin can click through and have a pop into the control, the cluster control for that available stack, whether it be vCenter, Kube control, or even, was that within the capabilities of the platform?
Not yet right now, but that's kind of the closed loop, right? Eventually you want to fix it. Yeah. So we want to close that. I mean, in short of, I don't think automatically fixing this is that easy to do. I know some vendor does that.
Terribly hard.
Terribly hard. So we want to at least go towards that direction for sure.
And on the back end, on the data presentation layer that's coming out, is there any sort of, I haven't had time to properly format my question. Is there some sort of queue that can be monitored so when the admin knows they're down to a problem, that someone or something else can monitor that queue and see what they're currently looking at, so that you could just watch for what tabular data and system is in that queue, just write a simple rule that pre-populate a kube control or some sort of simple CLI that can be pushed in through or some sort of command that can be pushed in the API of the controlling system?
Yeah, I think all the parameters that we monitor on, which is quite a bit, we all allow you to set, well, the way that we monitor is we automatically establish the baseline. That's auto-learned, and then you can certainly change that. And then based on that, we can generate actions.
And please bear with me, because I
Sure.
again, didn't have, this thought was not fully formed. What I'm looking at right now is colors and data on a screen. You have led us to the root of the problem. We know the system that is affected. We know the application on that system that is affected. And somewhere that in metadata, that system is tagged that it can be scale eligible or not. In this view, that the data presentation that we're looking at, where it's like model view controller or whatever you're using to make the pretty stuff happen, is there something on the back end that shows programmatically the state of what I'm looking at in a way that can be inspected through, that can be pulled through API or can be pushed up into a queue that could pull that same information, maybe in a screen side by side, so that the admin can literally go to the browser next and click remedy?
Yes. Yes, so we do, you're right. We keep track of this thing. Actually, we give it color or give it grading, we call it internally, all the time. Every minute we have a color or grading for it. And then the application is all written with RESTful API. So everything that you see is pullable. So that is a very high level answer.
So to echo back, what I heard you, what the question I asked was, as an admin, I'm looking at, I found the root cause of what is broken. And that as an application user or consumer of this application, it would be possible with some custom integration to have something polling aware of what that end user is looking at, where then I could pull that state and create the mapping of this system is scale eligible or not, and if it is, here's how we scale it, and here's the little click-through button to allow that admin to quickly go over and scale or not.
Yes, yes. Well, the very last part is to allow him to do that. We don't do that.
Yeah, that's external.
Right, exactly.
But
so yes, yes, it's doable.
I could, if this is implemented and for someone in my own world or externally, query the RESTful API to see what that admin's looking at in real time and use that information combined with other information to provide insights.
Yes.
That's neat.
Yeah, because I think we rely on, well, first we have a lot of default thing that we can already give you, but I'm sure every company has a different kind of a desire and different parameter in terms of making scalable, right? So that absolutely is something that we could definitely do.
Thank you.
Yeah, very flexible API.
Okay, this is another slide I want to share with you. It's coming from the China's largest sportswear retailer I mentioned before, right? They have been suffering the problem. They know they have 2,000 stores serving a lot of cash register, and every month some cash registers stop reading, right? They couldn't figure out what's going on, and 1 hour after install Uila, and they bring up this storage analysis view. And the interesting finding is, as you can see, there's a lot of red VMs and red ribbons, and interestingly, all those red ribbons converge into this logical data store. Oh, then the system administrator got excited. They finally locate the bottleneck. He quickly checked the physical storage attached on this logical data store. He realized this physical storage is very, very old. For some reason, it's left there, unupgraded for a while, right? After they upgrade the system, the devices, the picture turned green.
Well, I think the moral of the story is when we put it up on the screen, it's very obvious. It's that data storage store. So how can it take a public company that has 2,000 cash register not being able to find it months after months after months? Because only the symptom is the cash register being slow and once a month, right? And then secondly is when you have 2,000 cash registers out there, and then you got so many cash register server, you got too many, so many storage system, you got networking issue, you got, distributed remote site, retail store. I mean, they checked everything, but This is the part that until you really have the tool to visualize it, and then happen to be looking at storage, we automatically pinpoint it to storage for them. But until you have the tool, you're everywhere, right? You could be just going down the networking path for 3 months without finding anything. And they'd actually been adding servers, adding storage, adding memory, adding CPU power to the data center to no avail. And then you finally find out it is one particular storage device that is outdated they don't even know about, right? That's kind of the moral of the story.